Okay, so many people already came. So let's start the class. Okay, okay. So now can you see this slide? Am I audible properly?
Yes, sir. Yes, sir.
Okay,
Sir,
okay. So as I was discussing that we will start this quick sort with understanding the basic difference with merge sort. You see, remember one thing: quick sort is you can consider as a little bit modified version of merge sort. You know why I am saying this? The reason is, let's take a situation something like I have an array. Okay, I have an array like this, and many data is there. Many data is there. You want to sort this data present in this location. Okay. If you want to do through the merge sort, what we have seen that you have this whole the length of the array. If it is n, you are dividing the whole array into two parts blindly, each of n by 2, right? And then you are doing this. You are sorting this half and this half individually, and then you are merging, and this is goes on recursive somehow. Now you see, when a haphazard set of data is given to you without knowing the distribution of the order of the data in the set, we do a blind division. I mean, blind division between in the array, right? In case of merge sort. And in some cases, we find that this blind division may lead to an unbalanced array, unbalanced sub-array. So that's why, in some sense, we use a modified version of this merge sort algorithm as a quick sort, in a sense that we will not divide the whole array by 2 blindly. Rather, we will apply some intelligent algorithm to find what is the best place to divide the array into two parts so that I can complete the sorting in the optimum amount of time. Okay, is it clear now? So now see, let's start with the very basic understanding the strategy of quicksort. What is given over here? Yes, this is also a divide and conquer strategy. Yes, obviously, we will divide the array into some set of sub arrays where the number of uh, where each and every sub-array will contain more than one value, and we will keep on dividing until I'm getting only one value. That is okay, and then I will merge the result. And you see, the next point is this shows that it finds the element called pivot, which divides the array into two halves in such a way that elements in the left half are smaller than this part is very important, and elements in the right side is greater than the pi. Okay. So this pivot element is very important in quicksort. Okay. So now naturally question will come. Some question will come regarding the pivot element. We will one by one understand that. But remember one thing that if we have an array like this, and I have many data to sort over here, and each and every location contain value, any value, any location can be pivot. Theoretically, any location can be pivot. Okay. Now, for to avoid the complexity of our algorithm in some situation, we consider some special location as a pivot element location that I'm coming very quickly. Okay, so now here we have this basic steps of uh, the quickshot algorithm. What is given? There are actually three steps, mainly three steps. The first, pick an element, say P as pivot element, so that I have to select that which particular location will be considered the location of the pivot element of the chunk of the data, and that has to be fixed for chunk of any size. Now we have to apply this one. This is very important, and this is actually the intelligent algorithm to divide the array into two sub-arrays. Actually, it is given three sub-block because this particular algorithm consider the P, which is the pivot element, is also a part of the block where only one element will be present. So that means somehow, something like I can say that if I have an array like this, I will divide this array into three parts. This is the left half of the array. This is the right half of the array. And this is only the array part for the pivot. Okay. And it has to be, arranged in such a way that all this data present over here is lesser than pivot, and all this data it should be greater than 5. But what does it mean? It means that we are arranging the data into increased with increased value. I mean, in increasing order. If I want to do it in decreasing order, then this left half has to be greater than the pivot, and the right half has to be the lesser than the pivot. Mean each and every element in the left half will be greater than. I am not saying that this left half part will be sorted. I am saying that this may be unsorted. This may be unsorted. But all the element present in the left half has to be either greater than or lesser than. Depends on in which order I am arranging. And just opposite one in the right half. And then we will apply quickshot for left half as well as right half. How? We will do the same thing. We will consider the pivot element. What happened? Hello? Okay. So we will so let's see what's given over here. Those less than equal to P and greater than equal to P. Fine. Now and this third point is important. The third point say that sorry. The third point say that repeat the process recursively for the left and right subblock. Return quickshot to S1 and P quickshot S2. That is result of the quickshot 1 followed by P followed by result of quickshot S2. What does it mean? It's nothing but it's saying that since it is recursively saying that mean somehow we have a recursive call just like a merge sort here. Right? So that means I can say that I have an array of the whole part. Somehow I will find the actual position of the pivot element somewhere over here. So I will divide into two parts where this part will come. Okay. And all this part will come in this side. And similarly, we will apply the quickshot algorithm on these two different chunks. So I will get a somehow I will get a pivot elements position for individually for this chunk as well as for this chunk, and accordingly I will divide into two parts, taking this half and this half, this half and this half. So you see, as I will go downward, the number of element present in a chunk will definitely start in decreasing, and it will end when I have only one element in there, right? So the approach of the recursive call is something like that. So okay, fine. Now, how it is possible? Let's try to realize one thing. I mean, let's take a very simple example so that you can understand. Just a minute. Yes. So suppose I have, let's discuss with an example. I mean, suppose I have a like 4, 7, then 2, 5, 1, 3, 9. Okay. Suppose this is the unsorted set. I have to sort it using Quicksort. So at the very beginning, what you have to actually consider, you have to consider what position you will consider the position for pivot. As I told you that theoretically any position is possible, but to avoid the complexity of writing our program, what sometimes we do, we consider this particular position, the first position of the chunk, as a position of your pivot element. So that means here P represents 4. Okay, and I need two more pointers. Say for example, one is say L and one is say U. Okay, so L will point just next. Actually, the minimum, actually the first location of the chunk, but first location since I have considered for the pivot element, that's why the second location I have considered as L, and the last location is obviously U. Okay, so what will be my strategy is that I will keep on changing the location, the point position of L to this side and U to this side. Depends on some criteria. What criteria? So criteria can be like if I want to say if I want to arrange the array into in a increasing order, that means one thing I can say that somehow when I will get the actual position of the pivot element, that is 4, okay, then all the data present in this side should be lesser than 4 and all the data present over here should be greater than 4. That means if I find when I am changing my L to this side, the right side, if I get a value which is lesser than L, that should not be there in this side, should be there to some other side of the array. So that's why what we will do, let's see. So initially what I found that A of L, I mean basically A of L is what? Equal to 7. And you see 7 is greater than 4. Right? So if it is greater than, I will continue changing L towards right. That means L will be equal to L plus 1. So what will happen? Now where currently L is pointing? Currently L is pointing over here. Right? It is not pointing over here. And I will stop. If I find a value which is lesser than 4, I will stop. I found a value a of L is now equal to 2, which is lesser than 4. 4 is nothing but the pivot element. If it is lesser than 4, stop. So L will stop here. Similarly, I will keep on decreasing this U until I am getting something which is greater than the pivot element value. And you see, interestingly, where U is pointing is already greater than the pivot element. So you at the very beginning you will stop, right? And then I have to check what is the position of L as well as U. If I find L is lesser than U, then what I will do? I will have a swap between A of L and A of U. So swap means what will happen? This and this will have a swap. So that means what will happen? 6 will come here, 2 will come here, and other positions remain same. That 5, 1, 3, 9, and in this side also 4 and 7. Okay, and right now where L is pointing? Right now L is pointing somewhere over here after swapping. That now A of L equal to 6, and now A of U equal to basically 2. This is U and this is L. I have swapped just because so that I can increase this L and also decrease this U. So now after swapping, I will continue with the same strategy. I will go, this is now 6. 6 is greater than this. It remain pivot. Remember, this particular element remain pivot. Okay. So now A of L is greater than pivot. I can increase this L. So now L will point over here. Forget about L. I mean, now L is not pointing over here. Right? Similarly, what will happen when U will stop? E will basically stop again over here because this 9 is again greater than the 4, right? And what will happen? Again, I found that yes, A of A lesser than U is true. Yes, it is true. So again, I will have a swap between A of L and A of U. So I will have a swap between these 5 and 9. So what will happen? My new data will be something, a new distribution will be something like 9 will come here, 5 will come here, and other part remains same. 1, 3, and in this side 4, 7, 6. Okay. So now L is pointing over here, and your U is pointing over. Fine. Now what will happen? Where L will stop? Again, L will start changing its position, and this is my pivot as it is. Now you tell me what will be a new position of L where L should stop. Hello. Any idea?
1.
Sorry. L will basically stop somewhere over here. because this is lesser than pivot, which is not expected. The logic was until I'm getting greater value, which is greater than, value greater than pivot element, I will keep on increasing this L. If I find a value lesser than pivot, I will stop. So L should stop over there, right? It is now pointing over here and it stops. Fine. And what will happen for U? You see, this is greater than, and this one is greater than, just a minute. I had a mistake actually. I'm sorry.
স্যার আগেরটায় তো 5টা 4-এর থেকে বড় তো
Yes. I had a mistake. That was
ওটা তো একে যাবে।
yes, it will stop when L will basically point here, right? Point here, because this is lesser than 5. So you will have a swap between 1 and 9. So that means the new distribution will be 4, 7, 6, 5, then 9, then 3, then 1, then 2, like this, right? And this is my pivot. And this is where your L is pointing, and this is where your U is pointing, right? So now L will start changing its location. L is greater than, it is greater than 4. Now L can change its direction, and where L will stop? L will basically stop over here, right? L will stop over here because now L is pointing to this value, which is lesser than pivot. But what about U? Where U will stop? You see, 1 is lesser than 4. Fine, U can decrease in case of U. Again, that means now U is pointing to location where L is also pointing, that is 3. Still it is lesser than pivot. That means you can still decrease, and ultimately when U will come here, then A of U will be greater than the pivot element, and it will stop, because when it will find greater, it will stop. So now U is pointing on. Now this situation is different from this previous situation. Previous two situations, this is different. Where it is different? Difference is that now L is not lesser than U. So when L will be not, L will become greater than U. What to do? That means if L will be greater than U, then what to do? Then we will have a swap between A of P and A of U. Okay. So let's swap it. That means I will have a swap between this one and this one. So after swapping, what will happen? 9 will be the first value, then 7, then 6, then 5, then 4, then 3, then 1, then 2. So this is my, sorry. So that means this is my newly arranged array, where pivot element points position is this. So your array will be divided with this one, this part, and this. So this will be your subset 1, and this is your subset 2, where this subset 1 has to be sorted again by quicksort, and this subset 2 is to be sorted by quicksort. Now, by any chance, this particular subset become already sorted, you can see. But it is not true always, due to some special distribution of the data, suddenly it happened. I have taken a random set, that's why it happened. But it may not be happened, there is no guarantee, obviously. Now, one more interesting observation over here. If you sort this whole array just by yourself on a copy, what will be the what will be the order? It will be 9, then 7, then 6, then 5, then 4, then 3, then 1, then 2, then 1, like this. And what is the position of 4 in the sorted array? 1, 2, 3, 4, 5th position. And you see within this whole arrange, I'm getting position of 4 is also as same what we can have in the sorted array. That means quicksort, what quicksort does, quicksort actually put the pivot element in its exact position with respect to the sorted array, and then it divides the array into two parts. That is why when we will recursively call the quicksort for sorting the first half and second half of the array, then we will not include the newly created, the actual position of the pivot element. In case of merge sort, what we have said? In case of merge sort, say, let me delete all this first. In case of merge sort, what we have seen? We have seen that we are say we have an array, say A of L comma U. Okay. We have an array. L means the lower index and U is upper index. We are dividing into two parts. The first part will contain A of A to L comma M, where M is middle position between the L and U. And the second half contain A of what? M plus 1 to U. Right? We are not excluding this the middle position value. But in case of a quicksort, if you compare this strategy, compare the recursive call, it will be something like we have A comma L comma U. Fine. We have got the position, suppose position of the pivot element in M again. So in this the two recursive call will be there, and what will be the subset subset range, the range of the positions, sorry, range of the array locations, that is A of L comma, sorry, L comma M minus 1, and this is array is M plus 1 to E. I am not involving the position M because the position M is the position of the pivot element. And at the end of the, before recursive call starts, I have already got the correct position of the pivot. So I don't need to involve that. So this is the difference between quickshot, or very important difference between quickshot and matshot. And when you will write the program, you have to be careful when you will call when you will have a recursive call. If by any mistake, if you involve the position, the pivot element also, ultimately you will get some wrong output. Am I clear? Now tell me. If anybody has any doubt, you can raise your hand, or you can tell me. Okay, so nobody, actually I'm not getting any response, so I can assume that it's fine for everyone. Anyway, so we will end our class for today. Okay, next day, if possible, I will show you the how to write a program for quickshot. Okay. By the way, Anita, have you
Yes,
collected
sir.
the
Have
roll
taken.
numbers?
Yes.
All the roll numbers, right? Okay.
Yes. Yes.
So do one thing. I'm just ending this meeting for today. You send me the list in WhatsApp. Okay.
Okay.
So you can leave this classroom. Goodbye for today. Good night.